Identities, basic identities. On this first page here, you're going to see a list of them: the reciprocal identities, the tangent, cotangent, terms of sine and cosine, the Pythagorean identities, and the even and odds. So these are going to be very important. I encourage you to put a flashcard or keep this sheet out separate from your other stuff. This will be very useful for you. I want to talk to you about the odds. If you look at it, this has a list of the odd identities. Instead of sine and inside this parentheses negative x, and that means it's an odd, it gives me a negative sine x. Cosecant is odd because it's the inverse of sine. So therefore we get that brought out forward. Tangent, bring that out forwards, and cotangent, bring it out. Now the evens is the cosines. So that means that this negative sign doesn't come out right here. And the secant is going to be the same because it's the reciprocal of cosine. Okay, so the very first example here says odd or even. Well, it has the list of sine, cosecant, tangent, cotangent. So it is our odd function. Now let's talk about example 2. Example 2 says find the product and simplify your answer. Well, if you notice, we have a binomial times a binomial. And the first term in each parentheses are identical. The last term in each parentheses are identical. The only thing that's different is the signs. We have a difference. So that means we can use this, this formula or the shortcut where a squared minus b squared, where a is the first term and b is the last term in each parenthesis. Knowing that, I got 1 squared minus cosine squared. Or we can bring the square on the outside. Let me clean this up just for a minute. We're doing the extra stuff here. So this gives me 1 minus cosine squared alpha. All right, so now we need to determine what this is, because in mathematics, we simplify down as far as we can. And in this case here, it's not completely simplified. So we're going to use the Pythagorean theorem, Pythagorean identity of sine squared alpha plus cosine squared alpha equals 1. And if I solve for sine here, I'm going to have to subtract the cosine. And if you notice, sine squared alpha is equal to 1 minus that cosine squared alpha, which is this. So the final answer is sine squared alpha. Okay, so let's talk about our next equation problem. That mouse working. There we go. So it says, write the following expression in terms of sines and cosines and then simplify. So we're given this formula here, or this equation here, and we have this helpful table here. I encourage you to write it down if you don't already have it memorized. By this time, you should have it memorized. So what I'm going to do is I'm going to rewrite this in a format that's usable. So I got 8 plus the cosine of alpha, but tangent here we know is sine alpha over cosine alpha. And then secant, cosecant, we know is the inverse of sine alpha all over, well, we got cosecant, so it's 1 over sine alpha. So now let's rewrite this. Let's rewrite it like, bring the numerator and put it in parentheses. Some of y'all will skip this step, and that's okay. So whenever we divide a fraction, we're going to apply the rule keep, change, flip. So let's keep our first. Change to multiplication and flip our second. Okay, so next I want to use the distributive property. I'm going to distribute this to this and then this to here. So now I got 8 sine alpha, and I don't need the 1 underneath it. And then I got cosine alpha sine alpha over cosine alpha times 1 sine alpha over, or times sine alpha over 1. Okay, and this is just an extra step. You could have cleaned this up better. So the next one, I'm going to actually clean this up. So this is what I have. It's all over cosine, sine alpha. So now I got cosine alpha, sine alpha over cosine, sine alpha over sine alpha. All right. So, oh, my apologies, guys. I did a typo right here. It's going to be sine alpha times sine alpha. Okay, because these two were brought down to the bottom. All right. So what happens? I got cosine goes into itself once, sine goes into itself once. So now I got 8 sine alpha plus 1 times sine alpha. And now I'm going to clean it up. I got 8 sine alpha plus 1 sine alpha is 9 sine alpha. So this is my answer. All right, so now let's solve this next one. Use identities to find the exact value of alpha for the remaining 5 trigonometric functions. And we are given when cosine of alpha is equal to negative square root of 7, negative square root 3 divided by 7, where alpha falls in the 3rd quadrant. So let's look at that. So we're going to find sine first. And if I find sine first, let's use that, the Pythagorean identities. I know that sine squared alpha is equal to 1 minus cosine squared alpha. That was from solving it earlier. And so, and I know what cosine is. So if I do this, I'm going to plug in what I know, and we're going to square it. So now I got negative squared becomes a positive. Square root 3 squared is just 3, and 7 squared is 49. And now I need to find the common, least common denominator, which is 49. So I'm going to multiply that 1 by it. So now we got 49 minus 3 over 49, which is 46. 49 is my sine squared, but we want sine. So now what I'm going to have to do is take the square root of both sides to undo that square. So now I got sine alpha is equal to plus or minus square root of 46 over 7. And since it fell into the 3rd quadrant, we know that that sign is going to be negative. So we're not going to worry about the positive part. So we got our answer for sine. Okay. Now let's solve for cosecant and secant. Well, cosecant is the inverse of sine. So we're just going to take the inverse of sine, which is going to be a negative 7 square root of 46. Just check in my labs to make sure, or whatever assignments you're working in, if it's in your course shell, whatever it is, or textbook, make sure, and if they want you to simplify it and clean it up. If so, then that means they can't have a root in the denominator. And if that's so, we just multiply top and bottom by square root of 46. Secant is the inverse of cosine. So I know that I'm just going to flip it. So it's 7 square root of 3. And again, I would just make sure if they just want the exact or if they want you to simplify it more. Tangent is going to be sine of the alpha over cosine. Well, we know what the sine is. It's a negative square root of 46 over 7, and it's divided by our cosine. Our cosine's a negative square root of 3/7. And I'm just going to rewrite it where it's easier to read. And I'm going to apply that keep, change, flip rule. And what happens, my 7's reduce down to 1. So now I have a negative times a negative is a positive. I got square root of 46 over square root of 3. Now we, if we left it in that format, It'd be the 46. We can undo this and make sure and check to see if it wants it undone. If so, we just multiply top and bottom by square root of 3 and undoes the radical in the denominator. So just check to make sure whatever software you're working in, how they want the answer. Cotangent is the opposite. So, or is the reciprocal of tangent. So that means we're just going to flip this. And that's our answer. So let's move on to our next example. It says simplify the expression. So this one's not too bad at all. What do you notice? We notice that we have an odd here and an even. So knowing that that's an odd, that means that negative comes out front. So negative times negative here, right? Becomes a positive. And then this here is even, so that sign here, that negative sign doesn't come out. So it's just minus the sine of x divided by cosine of x. Now I've got 1, so you can say, if you wanted to look at it this way, 1 minus 1, right? Which is 0, and that is our answer. Let's do our last one. Use identities to simplify the expression. All right, so what I notice is that I have a cosine and then I have sine. So let's take the cosine and let's solve it for sine. If I do that, we're going to take the Pythagorean identity. And let's solve for it. So now I got sine squared alpha is equal to 1 minus the cosine squared alpha. So actually I went about it a little different. I was actually wanting the whatever I plug in to be sine up there because we got a bunch of sines. We could have done it that way, but we'd have to change everything. Well, I need to change one. So let's just solve for the cosine. I solve for sine. Let's solve for the cosine, which this is what it gives me. All right, so we're good. Now that we know this, I can rewrite everything here, right? I got 1 minus sine squared alpha minus the 3 sine squared alpha, all divided by the 1 minus 4 sine squared alpha. And what I notice is I have a negative sine squared alpha minus 3 sine squared alpha. So now I have 1 minus 4 sine squared alpha. And what happens? This is like saying I have 1 divided by 1. I mean, that's identical, right? 1 minus 4 sine squared alpha divided by 1 minus 4 squared alpha is 1. And that is our answer.